Welcome to Molecular Devices February webinar on taking analysis into your own hands, creating modules using MetaXpress Software. I see many names I see on the registrants of people who are customers and who have come to previous webinars. Welcome back. Product manager for cellular imaging at Molecular Devices, and Paula, longtime application and support scientist, will be co-giving this webinar today. If you need help or technical support, there's an 800 number that will work to get directly from the WebEx. And also, I'm going to go through a slide that explains how you can just send Q&A to both us and to WebEx. In the meantime, just to remind you, so I'm the product manager, and I'll be introducing the MetaXpress HiCon and screening systems and what's new with the product. And then Paula will be going through some examples and a live demo of modules using the software. We will summarize at the end with some Q&A that you can as we go. So please submit questions anytime during the webinar. We'll compile those and ask those back to the analysts at the end. To send Q&A, press on the Q&A button on the toolbar to expand the Q&A window, and with dialogue, and then you can type your question in there. Choose all panelists so that we all will see those questions, and then send button for us to be able to view those questions. Those not familiar with our product, what our offering is, we have a complete solution for imaging at Molecular Devices. On the left is a wide field high content screening system, Express Micro. We also have a confocal system, the MetaXpress Ultra. And we've really introduced ability to import third-party imaging images into our data management solutions. So the two systems, the wide field, the confocal, and if you have third-party generating data, they can all be imported into our data management offering and MDC store solution. This is for both image analysis and converting images into numbers to be done with MetaXpress and our MetaXpress PowerCore software option. In addition, all of that data and data management in one location can now be tied together for hit selection with the QDXpress software. Many customers, and they are encountering some, they repeat the same type of challenges that they're encountering in their screening centers. They want more accuracy to acquire and analyze screens. They have really expanding application space that needs to be addressed. They want to cut down wait time for screen visualization and quality assurance to existing imaging modalities or alternative imaging modalities. So we need to address these challenges to the market. Start with a little about what you in MetaXpress. That will introduce what Paula will show you later. So there are high content applications out there, all the way from apoptosis to zebra. So we like to we can address these applications from A to Z. And there's a long list of things on the left that need addressing that have high content screening. You need to approach those complex applications. You need a comprehensive toolbox for your imaging needs. And there are very well-defined applications to being very flexible for those well-defined applications. So there's an analysis continuum, and that continuum starts with robust acquisition, with simple tape-centric or customizable on-the-fly decision-making tools, which we have. For applications, we have application modules which are turnkey for common applications. For flexibility, we have journals, macros that allow for advanced and interactive applications. There's a bit of a possibly up in there. between those two extremes, and our new ability to create custom modules that will bridge that gap. And once a custom module is created, it allows you to make that now a turnkey application. So once it's created, there's very few parameters that need to be altered for that to now become a turnkey application. So if you want to go to custom modules, you can do a lot with custom modules. It gives you an expanded set of tools for making transmitted light images, and Paul will go through an example of that. You can do morphometric classifiers for analysis. You can objects within objects. And once created, custom modules are modules. They can be shared. You only need to modify a few parameters to run a different set of images. It can be run through our parallel processing option, MetaXpress PowerCore, just like an application module, and seamlessly integrate into our database once it's been saved. So here's a pretty good-looking that was without any fluorescent floor, and we can use this new custom module to segment those images. I'm going to go through some examples with much low contrast, more challenging images to show you the power of the new tool. You an all-in-one interface to create this tool. At the top of the custom editor is a place to choose your segmentation tools to be able to find your objects. You can use existing application module as maps to find objects. Modify your objects. You can modify your images. You select steps. Those steps show up as cards on the left with numerical value. There's 1, 2, 3, 4. Those are 4 steps. And the 4 steps correspond to a film strip at the bottom to see what you're doing as you progress through your image analysis routine. And if you go modify one of those steps, you just click on the image or click on the card to modify that step in the module. Here's an example of a module created in Metamorph, which is our sister product for research imaging. I have the same look and feel. All the steps corresponding to the segmentation are viewed at once. The module is created in Metamorph can now be to MetaXpress and reused there, and that module can be run through MetaXpress PowerCore. This example is the ability to find cells. The blue is the nuclei, the cells for the cytoplasm, and then find the intensity of the plasma membrane to find intensity and shape has to do with the cell's plasma membrane. So not only is the custom module there, MetaXpress is there in Metamorph, so you can do some assay development on your microscope and read the module in MetaXpress, high confidence screening assay. I've PowerCore a couple times, so this is our tool for removing analysis bottlenecks that might go with image processing. It's compatible with both custom and turnkey modules. The MetaXpress Software option, it drives your analysis to be faster than image acquisition, and you license the number of cores you need to run across to drive that analysis down. Between 4 and 16 cores is when you will be well of acquisition speed, and your analysis is going to be taking minutes. So just to remind you of a couple of other things that are new. I mentioned that you can import third-party images into our tool. This is a new tool that allows you to automate and schedule import and export of images from MDC Store. There's a number of formats that are compatible. A number of TIFF formats are easy, OME files, and there's a list of files that can be imported. And it automates the transfer images across sites or departments. It runs through a web browser, it connects to the MDC Store database, and you can schedule and automate the move of these images into and out of our database. Just to mention some improvements on the hardware. So if you know, we have the Excel system and we have the standard system, and the top compares the field of view of those two systems. The Excel is a bit over 3 times the field of view of a normal standard icon and screening system, and the The big box is runs a 384 well, and the small green box is the field with a standard camera. With the new XL, the lighting was changed and the detector was changed so that with a 4x objective you can capture more than a 384 well. It gives you number of objects. If you want low resolution, you can get one well in a single image, and large objects or high resolution you can collect images for those assays. This XL standard, the standard configuration of the XL system has a state light source that gives you on-demand illumination, eliminates mechanical shutters, and reduces support requirements. We will work with you to implement long life light sources that are validated with our system. This gives you us the flexibility to address a variety of applications and pick a configuration that works for you. This now enables UV, DNR, ratiometric imaging, expectation switching. So speak to us what you need if you system or our standard XL system are not adequate. So with MetaXpress Software, we are driving for fast and simpler. So we want to alleviate your day-to-day challenges to be able to run more screens, to expanding applications, performance faster, speed of analysis. We pride on maintaining quality images, and now the tools to all integrate with existing imaging modalities. On that note, I will pass the presentation over to Paula, who will through some examples of using the new software tools.
Hopefully you can see my screen now. Thank you, Grish, for the introduction. So I'm here to give a little bit more of a specific introduction to the custom module or CME and its use in a few specific applications. As I mentioned, with the CME, we are now able to simplify doing custom analysis in order to do tasks that are pretty common requests, and until recently we've had to address through journals, custom macros. Some of these include running multiple modules and combining the results together, running one segmentation but then getting measurements across multiple wavelengths, or segmentation of transmitted light images. So I'm going to show you some examples of these live in the software today so you can see exactly how quick and easy it is to set up a custom analysis. So I have 3 examples that I'm going to go through. One is a bead phagocytosis assay, and then also a bright field cell proliferation assay and the cell migration assay. So I'm going to go ahead and start with the bead phagocytosis assay. So, phagocytosis is a common, very important for the immune system, for immune cells to engulf bacteria and other holes, as well as dying cells. And in a typical assay, you'll have a particle that's coated with a ligand and also coated with some sort of fluorophore. And if the cell is able to phagocytose, you will see it engulf the particle, and you'll see it appear inside the cell. So, particular assay, we have cells that were had a bead supplied with the appropriate lens and 2 and a DAPI stain for nuclear identification, and the cells were treated either with a DMSO control or a compound known as cytochalasin D, which inhibits actin polymerization, so thus inhibits the phagocytosis. I apologize, I don't know what the exact ligands are on these samples because I didn't create the samples myself. The goal that we're trying to read out for this particular assay is a overall count of the cells, and for each cell, how many greenly beads are phagocytosed, and how many double-stained beads are phagocytosed. So you can see some example images. In the blue, or the DAPI, we have the nuclear stain. In green and red, the FITSI and Texas channels, we have beads, and when you overlay them, you will see that some of the beads are green only, some of the beads are red only, and some of the beads have both fluorophores. Okay. When you ran the analysis, you can just see quickly that with the treatments, we see a very distinct phenotype in both measurements, green-only beads per cell, as well as the green-red co-stain beads per cell. So the strategy that we're going to go through is to find all the nuclei and expand the nuclei to cover the cell area. Meaning we need to find all the green beads and all the red beads, find and then restrict that count to those just inside the cell area that we're looking for, and identify how many have the green and red stain and how many are green only. So at this point, I'm going to go ahead and switch over to the software. Okay, so see the plate color overlay. And if you go to an analysis tab, you'll see I have my normal list of modules. If I created any custom modules, they will be listed down here at the bottom. Actually already created for this, so if I wanted to edit it, I can click on Configure Custom Module. But for the purposes of showing how easy it is to put through that custom analysis, we're going to go ahead and create a new one from scratch. So I'm going to click on Create Custom Module, and this is in the Custom Module Editor. And just a few steps for this to open. Okay. So I apologize if this is a little bit small. I wanted to make sure that you could see all components rather than having me scroll around on the screen. So what you're seeing now are all my input images, the DAPI 50 Texas thread images from the site that I was looking at. And here will be all my steps for my segmentation and separate tab for measure when I'm ready to set up my measurements. I'm going to start with the segmentation. The thing that I want to do is find my nuclei. So I'm going to go to the Find Objects collection here. I have a few choices. And in general, we find for nuclei, auto find blobs or find blobs works well. Okay. So my find blobs here, and I need to select my source image. So I'm going to set this to DAPI, and it automatically updates to DAPI here. You may not be able to read this on the screen. It has a place I can enter an approximate minimum or maximum width and intensity above local background. Those of you who are used to using our CAN modules, this may sound familiar. But the added tool that will make this easier for us to work with, I'm just turning up the brightness here for people to see, is this button, the click to find. And so if I act this, I can now just click on various nuclei in each, and you see they are being selected on the right. And my values for the width and intensity are being updated as I click on these. I've gotten a representative sampling of the different nuclei I want to test. I can just go ahead and name my results. In this case, will be nuclei. Okay. And you will see how it's found all of those nuclei right. You can either look at this side-by-side view, or to see them overlaid, you can go to the split view option here. And this line becomes a divider that I can move left and right. Okay. All right. So if I'm with my nuclear segmentation, I can go ahead and go to the next step, which is to expand out the nuclei to create the whole cell area. And now I want to work with my nuclear mask, so I'm going to go to the Modify Objects. This is modeling an object mask that you've created. And you'll see you have options to grow and shrink objects. There's also grow objects without touching. And this one I want. So expand my nuclei, but then keep each expanded nucleus as a separate object. Source will be my nuclei, automatically updated with my name here. And I don't want ultimate growth, and I'm going to grow by a fixed amount. Give this a name. C is try different settings, how much it grows. That's 3 pixels. And I can do a larger amount. And this to me looks about right, so about 15 pixels. So the typical area for these cells. Okay. So now I'm ready to look for my beads. Go back to my Find Objects collection here. And the beads are nice and uniformly round. So for this, I can use the Find Round Objects tool. It pulls red image, so that's fine. I'm going to go ahead and select that. I'm going to, again, click to Find and click on individual beads. Okay, updated my settings here, and I'll just name these beads and click apply. Okay, and I'm the same thing for green beads. Find object. I'm going to select the city image. Just find. Actually, if you need to zoom in, you can use zoom button, or you can also use your scroll wheel. I'm going to go ahead and just click on some of these beads. Name the green beads. And click. And zoom out and make sure that it's found things appropriately. I need to at this point, I can eliminate clumps like this by adding in a filter. There's a filter mask option in here. I'm going to bother because I'm just going to include everything just to keep it simple. But it's very quick to add in. So I basically need to identify which of the beads have both green and red and which ones are just green. So for I use the tools Keep Marked Objects and Remove Marked Objects. So marked objects, my source will be the green beads, and the marker source will be the red beads, and the ridge will be the red beads. So you see only the beads that appear both the green and red are now showing in this green-red mask. I'm going to select the Remove Marked Objects. Source will be my green beads. My marker source will be the red beads. And now it will be the green-only beads. Okay, and now we'll see that all the beads that had green but do have red are what are appearing in my final mask. So I created a cell mask, create a mask of the green-only beads and the mask of the red-only beads. The green-red double-chain beads. So those are all the masks that I needed to generate for my module. So now I'm ready to go ahead and create my measurements. It's by default will save the overlay, the analysis overlay, which you usually want to when you're reviewing your results. So we'll go ahead and leave that on. What I need to do is to select my main map here, for my cells, and that's the expanded cell area. If I want to get any intensity measurements, etc., I can do that here, selecting an image. And if I don't need any of the measurements for this particular area, the expanded cell area, so I'm going to deselect all of these. But you can see from this that there's quite a number of different measurements available, including size, intensity, and morphological measurements. So what I want to do is measure different features within that area. So I'm going to add a feed group. I want to measure my nuclei and measure that from the DAPI. Okay. And all you need here is my nuclei, my nuclear intensity, and there's 1 nucleus per cell in this example, but I can add that on. And I can rename any measurements that I'm selecting, which is nice because I can customize it for my particular assay and makes it much more clear in the final readout. Okay, add another feature group. This will be for my green-red beads. The only measurement I am really concerned by here is the count. So I'm just going to select the feature count at the bottom and name my green-red bead count. And add another feature group here. Beads. Measurement I'm interested here is the count. Feature count, I'll name this green only bead count. Alright. And I can go ahead and click apply to test that. Show me on the right my cell by cell data. I'm going to and I can click on a cell, and if I look at this, it'll tell me this particular cell had 1 green-red bead and 6 green-only beads. If I toggle the overlay, I can see it looks. See, with my analysis at this point, I can go ahead and name and save my module. If I tweak any of the settings, I can just easily go back to segment tab and adjust any of the parameters and the results just as easily. So I can go ahead and save this. The normal MetaXpress screen that it's added the custom module successfully. So I'll click OK, and I go ahead and exit out of DME. You see it selected in the list. It's been added to my list here. And I can go ahead and cells to run it on. And you'll see through, it runs nice and quickly, much quicker than most of the custom journals that you might have tried in the past. Not running PowerCore, so with PowerCore it would run even faster. This is typed for well. Okay. Now you can see, here we go. I can see my measurements. You'll see all the measurements that I entered. So my concern is the green only bead count. per cell, and you can see the difference in the left, the cytochalasin D treated, as well as the control samples here. There's definitely a big difference in the output. And if I look at my results, you can see the overlay here. I can define those beads nicely. Also look at my green-red bead counts. That goes down just as I would expect. Okay. The phagocytosis assay. So that was reasonably straightforward. I'm going to go ahead and go back to my presentation now. Just remind you of what we did in this custom module. We found a nuclei, expanded nuclei to create my cell area. I found green beads, I found red beads, and then I looked at which of those overlay to find the double-stained green and red beads inside the cell region, and then also which were the green-only beads inside the cell region, and then I set up measurements and ran the module. Okay. This example I'm going to show you is a cell proliferation assay, which was done in bright field because for whatever biological reasons we did not want to use a fluorescent stain particular samples. We wanted to keep them alive and not put anything toxic on them. The goal of this assay is to count the cells and the area covered by the cells accurately using field only, or be done with phase contrast. And this will replace various traditional assays, including content with a fluorescent stain, which in the past has been sometimes difficult to quantify using bright field only. The challenge is when you're doing a bright field analysis, there are often artifacts such as scratches on your plate and wells. You can see in the bright field images, and also uneven shading, which is more apparent in transmitted light, can make thresholding difficult. And this is even worse at a low magnification. So this example we've got is at 4x, just to illustrate that. There are some examples. I actually only have 3 different example images that we're going to be using here for this. So you see on the left is one image. This is a very densely populated well. The cells are confluent and very close together. We have another one that's another phenotype that shows some of these. They're kind of shadowy because they're out of focus in the plane that we're looking at. And showing now the full image, so you can see all the shading effect. The centers of the images are definitely darker than the center of the image, which is brighter, and you can see the scratches. And with that, we're able to get a very accurate count of the cells that gives you consistent results across these different phenotypes. Okay, so the strategy used for doing these types of transmitted light images is to first apply some type of filter that enhances the your objects or your cells. So we have a few different filters you can choose from in the module editor. You use one of those find objects tools to find cells, and then if you need to do any kind of filtering to remove clumps or other undesirable objects, you can add in a filter at this point. And finally, you'll put in your measurements of interest and see how well it finds those cells, even with scratches there. Okay, go ahead and go back to the software. And now select my cell proliferation plate. So again, read at 4x. See different feeds we have here. That's this one. That's the very sparse one. And the intermediate with the scratches on. In my Run Analysis tab and create custom module. Okay. All right. Image. Let's zoom in so you can see. The thing that I need to do is to kind of enhance my objects in the image. And so I'm going to use one of our image filters. They're found under the Modify Image collection here. And you'll see a number of different tools here. There's arithmetic tools, a number of morphology tools, and some special filters available. Depending on your particular sample, your particular images, there's different filters that you might want to use. One of the ones that we find useful for transmitted image are the Gaussian filter and the LOG filter, which is the Laplacian of Gaussian. What I'm actually going to use for this particular example is the H basin, because these cells are quite small, and the H basin helps find some localized minima in the image. I'll select my source image, which is my transmitted light image, and then set a threshold. Okay, so for basically the difference between the cells and the local background. So I can just mouse over a cell, and you'll see the intensity is about 36,000, and then about 41,000 in ground. Some values. It's going to really highlight nicely. All right, so now you'll see an image highlighted all those dark localized minima, and it makes this look more like fluorescent image, which we know how to work with. This happens when I try some different values here. If I set something much lower, a lot of noise in the image, and if I set something that's too high, not them as clearly. So pretty simple. I'm just going to name my results here. Highlighted cells. And I can just go ahead and, again, run one of my Find Objects tools. So I'll use the Find Blob and my highlighted cells. Okay. And then again, do the Click to Find. And click on these cells. Oops. If I click and misclick, I can just hit Delete and remove one. Okay. Let's see how it did. I go to the split view because that makes it easier to see. Can move back and forth. And the corners of the images. And see. So I think threshold is maybe a little bit high. So I'm going to go ahead and lower that. I think that's fine. I'm finding now those corner objects that I was missing with a higher threshold. So able to click enough representative cells, you may have to manually adjust things like the intensity. I'm going the results cells. Last thing I might want to do is, just in sometimes we don't trust the objects that are right at the border. We're going to get accurate sizes because they're cut off. So option you can add in this remove border objects. And this is simply remove any objects that are touching the border of the image. Okay, you can see that side view, all the border objects are removed, and we'll get true cells here. Okay, that's all I need to do for segmentation. I can go now and set up my measurements. My metric will be my interior cells. My image measure will be the transmitted light. And the two measurements of interest are my total cell area here. Cell counts. Okay. All right, so it went ahead and did it, and you see again that although you see the scratches in the image, we're picking them up because they were too large to be were filtered out by that H-basin filter we ran. Okay. So I can go name this module. Okay. And now I can run analysis for the plates. Okay. My cell count total here. And if I click on any of the images, you can see the overlay. Find cells nicely, the shading, and it's avoiding the border objects. Okay, so it's transmitted light segmentation. Back to my presentation now, and we'll move on to the last one, which is the migration assay. This one, we use the ORIS migration assay, which is available from Platypus. And I'm sure some of you have tried this or at least looked into this. The nice setup for a migration assay. There's a plug that you put into the wells in your plate, and then you add your cells around the plug into the well, incubate them, and allow the cells to seed. And in basically this outer ring around the plug. And move the stopper, you'll have a hole in the middle of your well. And it incubates over time with that plug removed under different treatment conditions and see how much the cells migrate back into that hole. So is to measure the area covered by those migrating cells, or the area of holes. It would be larger without migration and smaller when there is migration. The challenge in this assay is finding artifacts that are outside of the area of interest, which you'll see some of the example images that we have. And the input that we're using is it's just a pretty iodide stain, a whole well image from the MetaXpress Micro. So this is the montage of some images. So you can see, as I mentioned, some of the wells have these outside the central hole, and those are just piping, the little div pipetter. That's what we're not to count. We want to count the center hole, how much of it is black and how much of it is covered by cells. And the plate had a few different treatments on it to show what the results were like. This measurement was the percentage of the area that was open. So lower the number, the more the migration, I believe. Okay. Right, so we're going to, by thresholding the image, to only find the center hole, we're going to filter by the centroid of our object, and it's going to measure the area. So very simple analysis. Okay, so you can sit around, turn off the scaling, the hole that we're looking for. Okay, so I'm going to create a custom module. Okay. The thing I'm going to do is just a simple threshold, select by intensity, and just I'm just going to type in the values that I already know. Okay, see that the objects are found, but I have a lot of false objects that I'm not interested in. So I'm going to add in a filter mask. Filter by centroid, by area. And this time I'm going to type in values that I already know. So by centroid Y, so you can see that are too high or too low get removed. I'm going to add in the centroid X. Remove objects that are too far to the left or the right, and then to be mainly found the. I'm going to put in a max filter just in case there's some sort of artifact in the image. Centroid Y and centroid X filters for position, max, minimum area filter, so I don't find anything that's larger than this is supposed to be. And so I can get a count across the whole image and add in a simple threshold. Just give me one solid mask so that I can get measurements across the entire image. My of objects is going to be the entire image, but I don't have any measurements from this. Your group of interest will be the hole. This, I want total area. And just to make sure you only get one hole per well. Go ahead and click I. Get one hole here and that whole area. Okay, so save my module and then return to MetaXpress and run a few selected wells. And it runs very quickly. And you can see the whole area there. Okay. So again, another very straightforward analysis using the custom module editor that would have taken quite a while with the journal to put together. Just wanted to show an overall a subset of some of the different modules that have now been created and are in use, just to give an idea of the breadth of assays that we can cover with this custom module editor, far more than we can with any modules. We're really excited about this because it really allows artists to develop new assays very quickly and get their experiments up and running much more quickly. I think at this time we're ready to take questions. This is just a reminder of what Tricia showed at the beginning of how to submit your questions. So press on the Q&A button in your question and ask all panelists. So please go ahead and submit any questions now.
So some of you have already met me. I'm otherwise maybe in touch with my colleagues Ben Howard of Christian Holtz. So we're all application CSEs for imaging. So as I described, if you have questions, now is the time to submit them and then answer them. So a couple of questions that are turned up. One of which is how long each measurement can take to be run. So obviously that is sometimes an obviously difficult question to answer, considering that it depends mainly on the module and the image complexity. So some custom modules are actually faster and others are actually slower than typical modules, but they do bring more flexibility, and they're kind of a compromise between application modules and journals. So some journals that you had to do before to do your measurements, then now you can actually do those measurements on the custom modules, which are actually compared with PowerCore. So eventually the speed of the measurement will be actually much higher. Is stitching images now easier? The custom module editor doesn't actually deal at all with stitching the images. So whatever images are open in a review play data as they are, basically as default, will be open in custom module editor. The advantage of the recent versions of the micro is that with a larger field of view, you would have a lesser need for stitching images. With a field of view that is 3.2 times larger than the standard micro, then for example, with a 4x objective, you get a whole well image, a whole well representation of a 384 well format. With a WebEx objective, you get almost the entire well of a 24 well plate. So that alleviates the need of actually stitching images. Question regarding application modules and their availability inside the custom module editor. So actually, all application modules that are active on your dongle for your analysis will be present in the custom editor when you load it up. So, and on a daily basis, you would use the custom modules to with masks. One I use a lot is, for example, cell scoring to allow me to create cytoplasmic masks, for example. And the way the segmentation is done in the custom module editor appears to be slightly better than normal application modules. So you tend to get a very good cytoplasmic mask, for example, even though your cytoplasmic marker is not forming very well. How does filter mask work? Now, filter mask is a feature that Paula used in the last example, the platypus assay. Now, filter mask works a little bit in the same way that IMA would work for those of you that have used it in the past. You basically can filter out artifacts or different intensities of interest out of your image to make measurements of what's interesting. And the filters can be based on intensity, on morphology, or size. And you would basically, if you have created your mask of objects, of all the objects that you want to filter some out of, then you would apply the entire mask on your object and look at the characteristics of those objects that you want to exclude and then construct your mask out of this. Custom modules be exported. Yes, the custom modules can be exported actually. So you can export them as an XML file that can actually email over to a different group. Actually, Metamorph, the latest version of Metamorph and MetaXpress actually share the same architecture. So whatever modules you would be making on Metamorph, say for manual very low throughput assay, you'd be able to export and to re-import in MetaXpress to run on an entire plate very quickly and very easily. One final question actually, which is, will there be a recording available? Yes, there will be a recording of this available in a few days. I suspect that the people attending the webinar will be receiving an email informing them of the availability of the recording. Right. So I guess we're going to end the webinar now because there are no more questions, and we're coming up to time now. Just to assure that if you would have other questions, additional questions, do not hesitate to contact us. As you had, I think, on the original slide, an email to the tech support or to the marketing department. Thanks a lot for your attending today, and have a good day. Bye.